Right now, there is a pervasive assumption about artificial intelligence that it's an autonomous genius. You turn it on, hand it a problem, and it simply hands you back the solution. We're applying these systems to some of our highest stakes problems. Take the climate crisis. To move away from fossil fuels, we desperately need to discover entirely new sustainable materials. Historically, finding a new material meant decades of slow, trial-and-error chemistry. Now, scientists use AI for something called inverse design. Instead of guessing, they give the algorithm a target characteristic, and the AI cuts a direct path through millions of chemical combinations to find the exact structure that works. It is the ultimate vindication of the autonomous AI narrative. You feed it a global challenge, and it outputs the highly advanced physical architecture for a better battery. If an algorithm is capable of designing next-generation energy storage, it should easily be able to help a 7th grader with their math homework. Sal Khan, the founder of Khan Academy, built an AI tutor called Khanmigo. The goal was to give every student access to a world-class, personalized digital tutor. But after rolling it out, Khan admitted something surprising. For most students, the AI tutor was a complete non-event. They clicked around, got a generic answer, and then abandoned it entirely. This creates a glaring contradiction. Why does the same software that maps complex chemical structures in seconds fail to help a middle schooler with basic algebra? To understand the disconnect, we have to look closely at what the chemists are actually doing with the algorithm. The researchers aren't sitting down and typing vague requests like, make a better battery. They are inputting highly specific datasets. They lock in target temperatures, pressure constraints, and molecular weights before the system ever runs. They operate using something called closed-loop optimization. The algorithm handles the heavy computational lifting, but the human experts are constantly steering it. The AI outputs a test result. The scientist interprets it, adjusts the parameters, and feeds it back into the loop. The inverse design process only works because the human has already defined the exact target characteristic. The AI is simply finding the fastest route to a destination the scientist chose. The AI functions as a high-precision extension of the scientist, operating only within the rigid boundaries of human intent. Look at how a struggling student interacts with a digital tutor. They're dropped at a blank prompt box and told to ask for help. Teachers observing these trial runs noticed a pattern. A student who is failing a subject usually doesn't know what they don't understand. If you don't know where your knowledge gap is, you can only ask vague, surface-level questions like, I don't get this. Mechanically, a vague prompt forces the AI to output a generic, shallow block of text. The student reads a response that doesn't actually target their specific confusion, and they disengage. The missing variable here is metacognition. That is, the uniquely human ability to think about your own thinking. You have to be able to actively identify what you don't know in order to formulate a question that yields a useful answer. This is why self-directed, curious students actually thrive with AI tutors. They already possess the metacognitive skills to interrogate the material, so they ask deep questions and get deep answers. Providing someone with access to infinite, instant algorithmic answers is useless if they lack the cognitive skill to formulate the right question. The rollout of these tutors exposes the flaw in the industry's access equals learning model. Artificial intelligence operates more like a mirror. It reflects and scales the existing clarity, capability, and intent of the person typing at the keyboard. When you put it in the hands of expert chemists, it amplifies their brilliance and accelerates their discoveries. When you put it in the hands of a confused student, it simply scales their confusion. These algorithms do not replace the need for human expertise. Instead, human expertise has become the primary bottleneck for unlocking the algorithm's actual value. This reality redefines the role of the human professional. To use a digital tutor effectively, a student first requires a human teacher. The modern teacher's primary role shifts to building the skill of inquiry, training students to recognize exactly where their understanding breaks down. The same principle applies at the macro scale. To discover the sustainable materials needed to power our future, we still rely entirely on brilliant human scientists to define the initial parameters. In a world where machines answer almost any question instantly, the most valuable human skill is knowing how to ask the right one.